Hello, my name is Angela Durbin. I am completing the introduction to the molecular lab. I will be performing activity 2, which is electron domain geometries. So I will go through and pause and play as needed, but essentially I'm going to be going through and making shapes with balloons and tying them, and that the tying represents the bond together. So I'll be going through linear geometry, which is 2 electron domains, trigonal planar geometry, 3 electron domains. Then I will be going to tetrahedral geometry, which is 4 electrons, trigonal bipyramidal geometry, which is 5 electron domain, and then the octahedral geometry, which is 6 electron domains. So I will pause and go through as I'm performing the exercise. Okay, for the first one, I have a linear geometry. And now I have the trigonal planar geometry, which this one has a 3 electron domain. And now I have the tetrahedral geometry, which is 4 electron domain. So here we are. Okay, now I have the trigonal bipyramidal geometry, which is 5 electron domain. And so with this one, it's a bit different because there is just a set of three. And so what I'll do is I'll twist the center, twist a set of 3 and the 2 together, so they're crossing knots in the center, so therefore that makes the trigonal bipyramidal geometry. It's a bit different process. So here we go. So these two are the 2 bonded together, and then they are bonded through this guy. Okay, the final geometry plane I have is the octahedral geometry, which has 6 electron domains. So we're going to just say 1 electron, 2 electron, 3, 4, 5 electron, and then 6 electron. Okay, we are going to twist 2 sets of 2 together. So this is the shape we had prior. So now we are also going to add another set of 2 balloons to this by twisting this third set of 2 balloons into the other 2 by crossing the knots in the center. So here we go. We have an octahedral geometry that is 6 electron domain, representing the different planes. And I believe that is all for this activity, but essentially it's basically just here to describe the 3-dimensional shapes of a molecule that we use to predict the valence shell electron pair repulsion, so basically the VSEPR model. And this structure is for molecules or ions that contain only nonmetals by minimizing the electrostatic repulsion between the regions of high electron density. So here we are. That's what all these are.